Yep.
Yep. So we'll do some notes first, and then we'll do the homework stuff second. So this is 2.7. 2.7 is almost an instant replay of 2.2 to 2.4, the quiz we took that we were pretty good at. Almost a total instant replay of that, just with 2 to 3 minor modifications. So when you look at this, you might notice one or two things different about this compared to your history with this problem. But this should look relatively familiar. Does anybody have one observation of anything that's out of the norm?
There's a pi.
There's a pi in there is one thing you might notice. Okay, if we step to this one, this also has a pi in it. They don't always have to have pi's in them, but one observation you'll have is they probably have pi's in them. Another observation of a mild difference?
Was it normally a theta?
It was a theta. So from this day forward, theta will always be their signal to you that you're using degrees. And an x will be their signal to you that you are instead using radians. And that's going to be the way they communicate with you the rest of the chapter, rest of the year. Anything with a theta is degree time. Anything with an x is radian time. So that's one minor modification, is you're going to be doing these tonight in radian town, because you're going to see x's and pi's. And there will be one other change will appear later. What was this number a description of?
Which number? The other distance.
Variable displacement.
That is the vertical displacement would be a -3. What was this about?
Amplitude.
The amplitude. Amplitude would be 4. What did that used to do for you?
Period.
Period directly, that was the period?
No,
No.
Okay, how did we used to do the period?
360 divided
We
by.
used to do, when we were in a degree problem, 360 divided by a number to get the period. That's no longer quite our choice. Anybody have a thought on, in radian town, how we would have to modify that approach?
Pi divided by,
Warm,
or 180.
cold,
2 pi
correct. Keep talking.
divided by the period number
Correct.
thing. Okay.
We're going to do 2 pi divided by that number to get the period. Because 2 pi in radians is the same as 360 in degrees. So if you do 2 pi dividing a fraction, what's going to happen?
10 pi. It's going to flip.
It's going to flip the fraction. The pi's are going to
Cancel.
cancel. And you get
Pi and a 10 with them on top.
disagree.
Okay.
Disagree. Do it on a piece of paper because it's disappearing from your brains aren't processing it right. A piece of paper to help your eyes might help your brain.
Wait, so what exactly?
2 pi dividing this fraction,
Would it just be?
which is flipping that fraction. What'd you
Would
say?
it just be 20?
It is a 20. The period will be a 20. Because the 2 pi is like it's on top of a 1. When the pi over 10 flips, the pi's will cancel. The 2 and the 10 are both on the top 20. Therefore, while we're at the period, we might as well do the frequency is 1 over 20. And then the other thing would be the phase displacement of 2. And now this is no longer a new question. Now we just use our skills that we've had like all chapter long. Question about the list build, almost a total instant replay from before. The only difference is to make the period, it's not 360 divided by anymore, it's 2 pi divided by. Something there? X-axis, which number would we want first on the x-axis?
2 2.
Agree with the 2. It's always on the x-axis that the phase displacement goes first. Then finish line,
22.
22. How did you get that?
20 plus 2.
Add on the period. The period is always x-axis fact number 2 to use. Middle number
12.
is 12 if we average.
7.
7 is true.
8. 17.
17 is true. Question about x-axis, anybody? We could have just as easily done the y-axis first. We didn't. Which number goes on the y-axis as your first move?
-3.
The -3. We always do on the y-axis, the vertical displacement is first. And then who takes effect?
Amplitude.
The amplitude. On the y-axis, the amplitude goes second. So top mark
1,
is a 1. Lowest mark,
-7.
-7. Try and help Abby out by a little bit drawing it somewhat to scale, just so it's a bit graphs. Yeah, I know you don't like those graphs, we'll maybe do that. And then check cosine. Okay, cosine, where's cosine start?
Top.
At the top.
1/2.
So like right here?
Yes.
I fooled you.
The 2.
At the 2. We're gonna start at the 2 line up high. And if we start there, we're also gonna
And there.
end there. At the 7 mark,
So we're going down to -3.
down to -3. Don't use this axis anymore. We're now down here. At the 12,
Go down to -7.
all the way down. 17,
Back up to the
back up
-3.
to some recovery. And do our best to not make these V's. And here we are. Something about that? So vertical displacement,
5.
5. Amplitude, 3. Period,
8 pi.
8 pi is true. So here's the story. If there is a pi in the problem right here, there will not be pi's on your x-axis. If there is not a pi right here, it'll be in the period, and there's going to be some pi's on our x-axis in a second. Frequency, 1 on top of 8 pi. Phase displacement,
-5.
it's negative pi. Let's do the y-axis first this time, just for variety. We go to
Up 5.
the 5 line. Topmost line
8.
is 8, lowest
2.
2. X-axis starting line,
5. No, -5.
negative pi. What number is in front of that?
1.
A 1. It's a -1. Finish line,
7 pi.
agree with 7 pi. What we can essentially do is tune out the pi's. Everything's going to have a pi on the x-axis, so you can just kind of take that for granted. If -1 adds on the period of 8, -1 adding 8 finishes us at 7. And right now we're trying to average -1 with +7. And if it helps you to even make the invisible 1 a visible 1, go for it. It doesn't bother me any. But halfway between -1, +7
3 pi.
is 3. Halfway between 3 and 7
5 pi.
is 5. Halfway between 3 and -1.
1 pi.
+1, which you could either have visibly or invisibly there as that 1. Anything about that zone? Okay, then it's graph time. Where are we starting?
At the 5 above the -1 pi.
Add a 5 above the -1 pi is correct. When we get to the 1 pi line,
Up to 8.
top, 3 pi,
Back on the 5 line. Down to the 2. And then back up to 5.
Is that question about that at all? I'm working this next one from the book. The homework is going to be on page 44. 1 through 4 is doing what we just did. They give you an equation, it has an x in it, that clues you in that it's radian pound, you make your list of facts like always and make it correct. 5 to 10, they go in reverse mode. Okay, so 5 to 10, it's still, everything is radians, but they're going to give you the picture, and you have to work from the picture inside out. So for 5 vertical displacement, there's no possible disagreement. We all have to agree on this. No wiggle room. Vertical displacement is definitely 5. Amplitude, no sort of wiggle room on that either. Amplitude is 2. Period. Also no wiggle room, but there's wiggle room as to how you approach how you're getting it, but you'll all arrive at the same destination. Somebody describe for us the system of how you get the period from the picture. What do you do?
Subtract 2, like, of the same place.
Subtract 2 of the same locations. So what are some matching location numbers?
Pi over 6 and 7 pi over 6.
Agreed. Pi over 6 and 7 pi over 6 are a match. If we subtract them, those aren't bad because they already have a nice thing for fraction subtraction, which is a common denominator. The pi invisibly has a 1, so if you subtract those, you get a pi. 6 pi over 6 might appear first in your brain, but pi is the best answer for that. So frequency, 1 over pi. And then the phase displacement, you literally could pick any number depending on how flexible you're willing to be about flipping or not flipping or whatever. Is it easier to find a sine number or a cosine number for this one? Cosine. Because for sine, you'd have to be in the middles, and you don't have any of the middle touch points labeled. So would you rather, to keep life simple, use a top or a bottom?
Bottom.
I'd say a top, because if you use a bottom for cosine, you additionally complicate your life because you have to flip it. I'd rather not get involved in flipping it, although it's not wrong. I'd rather use a top. So pick a good cosine phase displacement.
Pi over 6.
Pi over 6 would be fine. 7 pi over 6, just as good. If you wanted to use the ones that were over 3, that'd be fine. If you wanted to find the period, could you have used the fractions over 3 also? Yeah, because those are matches on the bottom. You just have to be cautious of the old minus makes a plus thing when you subtract that world. So then equation city, y equals
5
5,
plus 2.
probably plus 2. In our case, plus 2. In a flipping case, maybe a minus 2. Cosine in this case, there was no convenient way to do sine, but some of the homework could do sine. Let's leave the number empty here for a second.
X.
X today minus
Pi over 6.
pi over 6. A thought on that number?
Would be 2
Can you just
possibilities.
do 2 pi divided by that again?
Yes. Historically, what we've done is, again, the same thing. 360 dividing this is usually how we made that trip. 2 pi dividing that is how we're making the present trip, which is 2. And again, if this number in this position doesn't have a pi, your x-axis will. If this does have a pi in the equation, your x-axis likely does not have pi's. But there are going to be some pi's in that one. And that's the lesson. Okay, so tomorrow we have 44, 1 to 10. I already did 5, so you don't have to redo 5 if you don't want to. Tomorrow's Thursday. The next day we would have a worksheet due. So Friday the worksheet is due that I just gave you. Then we go on a weekend, hooray for weekends, and come back Monday. Monday would be a quiz that'll be like the 39 and 41 pages, plus this, just like the sheet that we'll review on Friday. Questions about agenda?
I was gonna ask, if we think it's easier to replace the pies with 180 to like find out the period, can we do that?
The period will have to be expressed in terms of pies. Like the list will have to have the pies in it. So that you just have to learn, you're gonna have to just learn to live with the pies to a degree. Something else? You can cut that for a second.